In this video, we're going to discuss how to write a set of numbers using set notation. And we're going to be working off of a set of numbers that has been drawn on a number line. So here, the red dots just represent which numbers we have marked on our number line. So we've marked the numbers 2, 3, 4, and 5. So to write a set of numbers in set notation, we use braces to denote that it's a set. And if we have a finite number of values, like we do here, we can just list them with commas in between. We don't even have to list them in a certain order. As long as they're all there, listed with a comma in between, and we've got those braces denoting that it's a set, that is set notation. Now, if we have a set of numbers like this, for example, let's just focus on the bottom picture here. We have not just graphed 2, 3, 4, and 5, right? We've graphed numbers between those integers as well, right? Like 2.5 is graphed here. 4.1 is graphed here. The number pi is graphed here because it's 3 point something. So in this case, we can't list all of the numbers out. So what we're going to do is we're going to use set builder notation. So for set builder notation, what we do is we write set of all x such that. So this vertical line segment here means such that. So this basically means, hey, I'm going to describe this set of numbers to you, and I'm going to do it with an expression. So I got to tell you what variable I'm going to use. So this says the set of all x such that, okay, the set of all x such that what? Well, such that x is between 2 and 5 inclusive. So x is greater than or equal to 2 and less than or equal to 5. So again, we can't just list 2, 3, 4, 5 because we've graphed more than that this time. Here we had only graphed 2, 3, 4, and 5. But now we've graphed numbers between as well. Going back to this picture here, different books will use different styles of drawing an interval of numbers on a number line. So both of those mean the same thing. They mean we're including the numbers 2 and 5 in the set that we're describing. We have to note that because we might have a set like this. So now we're talking about the numbers between 1 and 7, negative 1 and 7, sorry, but we're not including negative 1 and 7 this time. So you might wonder, why do we have to note it that way? Why can't we just go from 0 to 6, right? Well, again, there are numbers between the integers. So if you stop at 6, you're actually excluding now numbers that should be included, right? We've graphed numbers like 6.5, 6.9, 6.99. So you can't just stop short of 7 because anywhere you stop, you've excluded some numbers. What about 6.99999? Right? You can just keep going. So that's why we have this notation saying, all right, we're going to go right up to 7, but not include it. So that'll look like an open circle or parentheses. So for our set builder notation, it's going to look really similar. We're going to write the set of all x such that, and then we're going to describe what a number x would look like. Well, it's going to be between negative 1 and 7, but this time we don't have the or equal to on the inequality. This is going to look really similar, but here we've included the 0 and we've not included the 4. So this will be the set of all x such that x is greater than or equal to 0 and less than 4. So it's possible that maybe one endpoint is included and the other endpoint is not. Now you might have just one endpoint and then an arrow. So here we're shading all the numbers starting from 2 and going forever to the right. So if you think about what kind of numbers that would be, right, going to the right means we're getting larger. So numbers like 3, 4, 5, right. Numbers that are not shaded, numbers to the left, should be things like 0 and 1, right? So the numbers that are graphed here are all the numbers from 2 going up, so anything greater than or equal to 2. So for set notation, we would write the set of all x such that x is greater than or equal to 2. Similarly here, we've got only one boundary. We're at 5. Sometimes it helps to add some more numbers to the number line, right? So we're starting at 5, going to the left. So we're including all the numbers that are less than 5. We're not including 5 because we have that open circle. So this will be the set of all x such that x is less than 5. Okay, this is kind of different because here the numbers are not all connected to each other. We've got a gap and then we have some more numbers farther down the line. So there's a couple different ways we could write this set. Actually, even some of the ones we've already done, maybe you could write in a different way, because when you use set builder notation, you just have to describe the set accurately. So there might be different ways to do that. So one way to write this in set notation would be to say the set of all x such that x is less than or equal to 2, or x is greater than 10. So we're describing that any number included in this set would have to be less than or equal to 2 or greater than 10. Another way to do this would be to write a expression for each kind of section of the number line and then combine those to make one set. So for example, the left end, the numbers at the left end could be described with this set, the set of all x such that x is less than or equal to 2. And then the numbers at the right end could be described as the set of all x such that x is greater than 10. Now to combine those two sets and make one larger set out of them, we use this symbol here, which stands for union. That's why it looks like a big U. So a union of two sets means we're just taking two small sets, combining them into one larger set. So either of these would be a perfectly acceptable way to write this set of numbers in set builder notation. There's going to be a few ways to do this one as well. So one way, so basically what we have here is we've shaded the entire real number line except for the number 1. So basically it's all real numbers except for the number 1. So that's probably the simplest way to do our set builder notation here. The set of all x such that x is not equal to 1. It's probably the most concise way. We could also do this using one of the methods that we used here. So we could say set of all x such that x is less than 1 or x is greater than 1. Because those are the only two possibilities, right? Can't be equal to 1, so it's either got to be less than 1 or greater than 1. Though that kind of describes like the two sections that are separated by that open circle. So you could also do this one with a union symbol as well. You could say the set of all x such that x is less than 1, union with the set of all x such that x is greater than 1. And you might be wondering, like, why would we bother to do it that way? Any of these three ways of writing this are perfectly acceptable. The top one is probably the easiest. That's probably what I would have written if I was just trying to describe this quickly. The reason I wanted to talk through the other two methods is because those will tie into the next video on interval notation. So hold that thought till the next video. Here we've graphed the entire real number line. So this is all real numbers. So in set notation, you could just say set of all x such that x is a real number. Some of you maybe have seen before that the set of all real numbers is sometimes written with this big goofy looking capital R type looking symbol. So that's another way to write all real numbers in set notation.